So this is what we're going to cover here: IP version 4, multicast, unicast, segmentation, subnet to meet requirements, variable length, subnet mask, structure, design. Do you guys know what VLSM? Masood, did you learn? Well, not on your own, but was it taught in any other module?
No.
All right. Okay, so as you know, IP version 4 consists of network and host addresses, right? How do you know what part of the network ID is, what part of the IP address is the network address, and what part of the IP address is belong to the host? How do you know that?
With subnet mask.
With the subnet mask. Okay, there are classes of IP addresses A, B, C. Okay, and you can tell by looking at the IP address, if it's class A, class B, or class C, and therefore you know what part. So if the network starts from 10, you know that the last three octets are belong to the host ID, and the first octet is belong to the network ID. But this is no, but it's not always true, because you do subnetting, you customize the network. So therefore you have to look at the subnet mask, as Masood says. So the subnet mask tells you what part of the network ID. So all ones is the network, and all zeros is the host. Okay. So as you can see here, the subnet mask, 32-bit address, and these are the prefix. So in a lot of documentation, instead of seeing the whole subnet mask, like 255.255.255.128, you will see the prefix, okay? Which means 8 bits are used for the network ID. So that means the first octet is part of the network, the rest are belong to the host. 16 is class B IP address. The first two octets belong to the network, and the last two belong to the host. Same thing, 24. So, and then when you do custom subnetting, when you take the bits from the host and add it to the network, then your prefix changes like this. So that means 27, the first three octet plus 3 bits from the last octets are belong to the network. So prefix are all. So in the exam, probably if you're gonna take the CCNN exam, they will give you the prefix instead of the whole subnet mask. Okay. Okay, the logical end. So as human, we can look at the subnet mask, and we can just tell that this IP address is belong to either the same network, or the distance network, or the remote network. But the computers, what they do, how they determine if the network, if the addresses belong to the same network, or it's belong to the different network. So if it's belong to the different network, they will send it to the routers. But how do they determine? They use a process called ending, okay, where the host address so you have the host address and the subnet mask, right? And what they do is they calculate, okay, the ending. And this is how if 1 and 1 is 1 and 1 equals 1, 0 and 1 equals 0. So only time it equals 1 when both are 1 and 1. And this gives you the exact IP address. Okay. So the ending process is used to determine for your computer, even for your computer, where to send the packet, either to its destination in the local area network or send it to the router. Okay. All right. So there's a very important thing about the broadcast. There's a broadcast address. Broadcast address is sent to all the hosts on the network. Okay. And then you have usable first usable host and the last usable host, uh, meaning the IP address then can be used or can be assigned to either host or the router interface, meaning usable, because there are IP addresses that cannot be used. For example, broadcast address. You cannot assign a broadcast address to a specific host, same as a network address. A network address cannot be assigned to a specific host because it's belong to the whole network. So let's see this little video.
All devices on an IPv4 network need a 32-bit logical address in order to communicate. This 32-bit logical IPv4 host address consists of a network portion or network ID on the left and a host portion or host ID on the right. The length of these depends on the size of the network. Larger networks will have a longer host portion. A network can be thought of as a range of addresses. All devices on the same network have the same bit pattern for their network ID, but they will have a different host ID. Some addresses in this range are reserved and have a special name and meaning. For example, the first address in the range is used to identify the network itself and cannot be assigned to any host. It is referred to as the network address. The last in the range is called the broadcast address and is used to send a message to all devices on the network.
You're muted.
So a broadcast address is all ones in the host portion, and it is used to send packets to all the network. Again, as a network engineer or network technician, you don't send broadcast to all the host. It's the application or the services decides if they need to send broadcast or not. Okay, so your job is to minimize the broadcast, or in some cases eliminate the broadcast
At once. It also cannot be assigned to any host. All the IP addresses between the network and the broadcast addresses make up the usable or valid host range and can be used to address the hosts on the network. Let's take a look at how these addresses are determined. In order to forward data, a device needs to know what network it's on. Using their host IP address, their subnet mask, and a process called binary ANDing, a device can find what's referred to as the network address. This address represents the network to which the host belongs and will be slightly different than its host IP. To do this, the device compares their host IP and their subnet mask bit for bit. If the bit values are both a binary 1, the result is a binary 1. If one or both of the bit values is 0, the result is a binary 0. Let's take a look at an example. Let's say we have a PC with a host IP address and a subnet mask of 192.168.2.38/24, and we'll use ANDing to find the network address of the host. Here's the host IP in binary. Here's the subnet mask in binary. If we compare them bit for bit, we can see that a 1 and a 1 results in a 1 and a 1 results in a 1, a 0 and a 1 results in a 0, a 0 and a 1 results in a 0, and so on until we have compared all 32 bits. Notice that the last octet is all binary zeros. Because we are using a /24 subnet mask, the first 3 octets represent the network portion and the last octet is the host portion. Network addresses will always have binary zeros in their entire host portion, however long it is. In this case, the last 8 bits. If we convert to dotted decimal, we can see that this host belongs to the network 192.168.2.0/24. Now let's determine the broadcast address for this network, which is used to send a message to all devices on the network at once. Whereas the network address had all binary zeros in the host portion, the broadcast address will have all binary ones. Since the host portion in this example is just the last octet, to determine the broadcast address, we keep the network portion the same and change the host portion to all binary ones. This results in a broadcast address of 192.168.2.255. Next, we'll determine the usable host addresses, which lie between the network and the broadcast addresses. The first usable host in binary will be all binary zeros with a binary 1 at the end of the host portion. Converting to dotted decimal, this tells us the first usable host on this network is 192.168.2.1. Lastly, we'll determine the last usable host, which will be all binary ones with a 0 at the end, the opposite bit pattern of the first usable host. Converting to dotted decimal, we get 192.168.2.254. Let's recap our calculations. We began with the host IP address of 192.168.2.38/24. Using binary ANDing, we determined that this host belongs to the network 192.168.2.0. Keeping the network portion the same, but placing all binary ones in the host portion, we determined that the broadcast address for this network is 192.168.2.255. Again, keeping the network portion the same but changing the host portion, we determined that the usable host range for assigning addresses to devices on this network is 192.168.2.1, which is one number up from the network address, and 192.168.2.254, which is one number down from the broadcast address. You can see that our original host IP address falls within this range. Things to keep in mind when working with IPv4 addresses. All IPv4 host addresses are 32 bits in length. A portion of the address represents the network that the host belongs to, and that starts at the left. The remaining part is the host portion, which identifies the host on the network. And there are 2 special reserved addresses on every network that can't be assigned to hosts. One is the network address, which is the lowest in the range of addresses and represents the network that all the devices belong to. And the other is the broadcast address, which is the highest address in the range and can be used for a shout out to all devices on the network at once. Thankfully, there are shortcuts you can take for calculating these addresses without having to convert to binary first. But examining these addresses at the bit level should help you understand how network devices interpret them and also how the dotted decimal format is derived.
Right. So this is important to remember. A lot of people, they don't they forget when you're subnetting, which we're gonna do later on. When you're subnetting the network, you have usable host. So you have to eliminate. You have to the network ID and the broadcast address, which is the end. Okay. So here, so you have a network, and so these the usable ID, let's say 1, 10, 55, these are usable network ID that you assign to host or devices. Okay. Keep that in mind. When you're assigning the IP addresses, you have to consider one IP address for each router interface and also an IP address for the switch management that you assign to VLAN, okay, switch management port. And here, the network ID 192.168.10.0 is the network ID that cannot be assigned. So this is the network address. All right, so when you're reviewing this chapter, go do this activity, okay? And then there are some quizzes. All right, next chapter. So, okay, again, we have, I think we have covered this. A unicast address is an address of a device. It's one-to-one address. A broadcast address is sent to all the devices on the network, usually used by services or applications. Okay, and multicast address is sent to the group of devices. Again, this is used by specific applications. All right. For example, gaming application uses multicast addresses. Okay, why it's important to know all these unicast, broadcast, or multicast addresses? Again, for troubleshooting purposes, if you have a lot of broadcasts on the network, that can bring down your whole network or slow down the network. So you have to find out what is causing that broadcast. Is it a legitimate services that causing the broadcast? If that's the case, you have to configure the service to limit the broadcast. Or there could be, and there are a virus on the network that is generating all this broadcast. Okay. All right. What is the difference between, let's test your knowledge. What is the difference between a public and a private IPv4 address? Anybody knows the difference between a private and a public IPv4 address?
Private uses in local area network and private in WAN, uses in WAN.
And a public used on the internet. Why cannot you use a private IP address in a public network? Why there's a division?
Because many of the local area network use the private IP address.
Okay. Anyway, the main difference as Masood is right, private IP address is used mostly in local area network. That's why and I'm going to explain why I said mostly, because now private IP addresses are also used on the internet. For example, I don't know if my IP address from my internet provider is the private IP address. It's not it always used to be the public IP address, but now it's a private IP address, and I'm going to tell you why. Okay, first of all, a private IP address cannot be routed on the internet. Routers on the internet, when they receive private IP address, so either let's say 192.168.1.10 or 10.0.0.0, whatever, they discard the private IP address. They are meant to use in a private network, not on the internet. But because of the scarcity of IP addresses, the service provider, they create the network as a private network. Okay, like for example Bell, and they use private IP addresses, and then that network is connected to the public network. So when they assign, when you're connected to the Bell or any other ISP, actually you're connected to their private network. So the reason I'm explaining this, because one student says, but sir, you said the private IP addresses are not used on the internet, but my address is private. So this is the reason. The service provider have created a private network in each area, okay, using switches and routers, and then they are connected to the public network, which is the internet. So you go through, so there is your own private network, then you're connected to ISP's private network, and then ISP connect you to the public network. Okay, so that's why so the private addresses are not routable on the internet. Okay, they has to be translated to the public IP address. That's why you need network address translation protocol. And there are three types of private IP addresses: class A, class B, and class C. Okay, so these are the addresses you can use on your network, in the private network. But if you want to connect to the internet, you need at least one public IP address from the ISP. Okay, and the since private IP addresses cannot be routed on the internet, because all internet router, as soon as they receive a private IP address, they discard. So you need a software, a service called network address translation, which translates. So in this case, you have ISP1, ISP2, ISP3, which so the net, what it does is it takes the private IP address and convert into the public IP address. Okay, so here typically you have a public IP address that is assigned from the ISP, and this is the private IP address, and this need to be converted or translated into the public IP address. Okay. Okay, so here there are some DMZ stands for demilitarized zone. It comes from, well, military terminology, I guess, right? So what do you do in a typical network? You connect all your servers in one subnet. Okay, a separate subnet, and this subnet is configured with the public addresses, so people can outside of your network, people can access those servers. Okay, and then you have a subnet with the private IP addresses. This is for internal use, and there's a firewall router that connects these different subnets. Okay, so why you have to separate your public servers from the internal network, so you can provide more security, so outside users are not able to access your private network, where you might have your private data, for example, payroll information, client database that is not required to be accessed by the general public. Okay. And then you have special use addresses. For example, a loopback address. A loopback address test so if you cannot access another host on the network, or you cannot access the internet, you can use a loopback address to see if IP IP protocol is correctly installed on your computer. Okay, so what it does is it ping itself the loopback address. You cannot assign loopback address to any host. So this is for troubleshooting. And then you have link local address as the automatic private IP addressing. Their automatic private IP address. So if your computer is not connected to the network or any network, if the DHCP server is not available, that address is automatically assigned. So if you ever see an address starting from 169, that means mostly that the problem is with the connection. There's no connection to the network. Okay, either broken cable, could be a problem with the network card. Okay. So these are the classes of IP addresses. You guys probably already know. You have class A addresses, class B, and class C. Class A has more hosts and less network. Class B has more hosts than class C, and class C has less hosts than class B and class A. Okay. So it's all about how many bits are being used for the network ID and how many bits are used for the host ID. And how the IP addresses are assigned. So if you are a company, an ISP, a new ISP, and you need IP addresses, obviously you need public IP addresses so you can connect your client to the internet. And for that, you have to go to your regional internet registries. Okay, there are multiple registries depending on the region. So you have a registry in Africa, Asia, North America, and the job of these, and what they do is they assign block of IP addresses to organization, public IP addresses, okay, to organization. Now, these days, if you're if you are not an ISP, just a company, private company, you don't need a public IP address. Okay, you can use private IP address, and to connect to the internet, you can just use the IP address from the service provider. All right, now we're going to talk about subnetting. And before we talk about subnetting, we need to know, why do we have to subnet in the first place? Okay, why do we even need to subnet? Okay, we need to subnet because it's uh, uh, it's a good practice to segment your network, meaning you divide your network into smaller network. Why do you even need to segment the network? Anybody knows? I think you have done segmentation in module 14. Why do you have to segment the network? Why not just use 1 or 2, 3, 4 switches and connect all the hosts to those switches? Why come up with different subnet IDs? Then you need a router, okay, that connects different segments. Why do you need to segment the network? What are the reasons?
For classification or grouping the network.
Classification. What else?
To reduce the broadcast traffic.
To reduce the broadcast traffic. What else? Very important. I just talked about it before. DMZ. Security. Okay, so both of you are right. Okay, so to reduce the broadcast traffic, meaning improve network performance. Okay, that includes reducing the broadcast traffic as well. Okay, separating heavy network user in a separate subnet. Security, like for example, if you have a researcher researching on a product, even though there are only 2 or 3 people, okay, and research costs a lot of money, they require more security than your marketing department. Okay, so you put them in a separate segment or separate network, and assign special security to that group of user. DMZ zone, meaning if you have a web server that public need to access, okay, you have a server that is running Google Cloud for e-commerce purposes. Not Google Cloud, but for e-commerce purposes. So any type of server that is accessed by the public, you put it in a separate segment or a separate network, and you configure security only for that segment. Keep that in mind. Security softwares are very, very expensive. So, and they're mostly based on the cost based on licenses. So if you don't need high security for a specific user, you don't use high security for those users. You just buy licenses for the user that really need that type of security. So the segmentation has many reasons. Improve network performance, and plus, when you connect many hosts with just one switch or multiple switches, it increase your broadcast domain. Okay, so it generates more broadcast. So so the segmentation limits the broadcast domain. So when you have a large broadcast domain, you have more traffic on the network, and it's unnecessary traffic. Broadcast is not necessary all the time. So what you have to do is you have to limit the broadcast by segmenting the network. Okay, the only device that can limit the broadcast is the router. Switches, they can minimize the broadcast, but initially they pass the broadcast. Okay, how networks communicate, how different segment or the networks communicate with each other. They communicate with the router. So for example, so this is a very, very typical setup. So those of you, if you guys, if you're going to be working in Montreal actually is the hub of mid to small businesses. We don't have multi national companies headquartered here in Montreal. So this is what you're going to see in most of the businesses. When you start working, you will have a router connected to the internet, and depending on the size of businesses, you will have multiple subnets. Okay, you will have LAN 1, LAN 2, LAN 3, depending on the size of business, or maybe it's just one subnet if it's a small business. Like one of the student works for a law firm in downtown, and I just recently talked to him. So we were just talking, and yeah, so they have 100 users, and they're connected to the internet, and they only have one subnet. They put all 100 users in one subnet. Okay, and so it depends. It depends what type. There's no formula or technique. Oh, how many subnets do you need to create? Like, okay, it's not depends on how many users. It depends on multiple factors. How many users are there, and what type of applications are being used. Some application generate more traffic than the others. Okay, graphic application generates more traffic. So even though you have only 5 graphic designer in your organization, and they all work collaboratively on one project, so you put those 5 designers in a separate network. Okay, and also the device type, subnetting by the device type. So you also subnet based on what type of device you're using. Okay, and obviously subnet, one of the most common reason for subnetting is the location. For example, in our department, computing support department, we have 10 subnets. Okay, even though all these subnets are in one floor, but they're based on the room number or the class. So each class is a separate subnet. So we divide them based on location. Okay. So if, let's say, for example, because we used to teach deployment and imaging. So if one class is working on imaging, it will not affect the whole network. Their traffic stays in within the class. So that is very common reason, to subnet your network. Okay. Okay, subnetting on the octet bar. So what is how do you actually subnet a network? Now, in today's network, if you're working for a company, you actually never have to do this. You never have to subnet a private network. Meaning you would never have to take an IP address, borrow from the host portion, and add it to the network ID. Why? Because of the private network, you can just create multiple subnet IDs. You don't have to borrow. For example, let's say you need 10 subnets, right? You can start, your first subnet could be 192.168.1.0, and second 2.0, 3.0, up until 10. There you go. You have 10 subnets. You don't need to do any borrowing. You only have to borrow what you have learned before, where you take the bits from the host portion and add it to the network ID. You only have to do that when you're working with the public IP address. Okay, the public IP address has to be configured legally, meaning you have to borrow the IP addresses and you come up with different network IDs, which you don't have to do in today's network, mostly unless you're working for ISPs. Okay, so you borrow the IP address, or you take the bits from the host portion and you add it to the network portion. So that gives you more network IDs with less host in each network. Okay, so here number of subnets. So if you borrow, let's say you have a 24 bit network. It's a Class C network, right? And so if you borrow two bits, you have number of hosts 126, and then your prefix length would be 25, and then you calculate the subnet mask, okay, for the whole network. So this is the minimum bit you can borrow are 2. So here you have 4, 8, 16, 32, 64. So let's see the clicked. So let's look at this video, the process of subnetting. It's an 8-minute video.
Now, I want to take a moment to point out that subnetting makes sense from the binary perspective. In other words, when we take the IP address and the subnet mask and convert them to binary, I have the IP address on this row here, I have the subnet mask on this row, converted to binary, that the computer and the router are able to logically and or combine the IP address and the subnet mask and find the network address. In other words, this ANDing process is a logical process of ANDing. So a true and a true makes a true, 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 false and a true makes a false. And if we do that and logically and the IP address with the subnet mask, we get the network address. So 192.168.1.10 logically ANDed with 255.255.255.0 produces the 192.168.1.0 network. This is at the core of the IPv4 address and subnet mask and subnetting in general. What about non-classful subnet masks? We've seen that the Class C subnet mask is /24. We've seen the Class B subnet mask /16 and the Class A subnet mask /8. But what if we use classless masks? In other words, what if we have a /25 subnet mask or a /18 subnet mask, creating a 255.255.192.0 subnet mask? Or for that matter, a /12 subnet mask, 255.240.0.
So we have three classes of subnet mask: 8 bits, 16 bits, and 24 bits. So 8 bits is class A, 16 bits class B, 24 bits class C. And when you see a subnet mask that is not belong to any class, this is called classless subnet mask. And these are the subnet that are customized, meaning the bits are borrowed from the host portion and added to the network portion. So you see, they're not part of any classful subnet. So here, that means 1 bit is being borrowed from the host portion.
0. How does that work, and how does that change the networks that are created by the combination of the IP address and the subnet mask? This is called subnetting. I'll explain it using an example scenario. Let's start with a classic Class C network like 192.168.1.0 with a /24 or 255.255.255.0 subnet mask. If we want to subnet this 192.168.1.0 network, what we need to do is go into the subnet mask in binary, which we can see on this row right here. And what we do is, to change the subnet mask, we borrow bits from the host portion of the address. This is done from left to right. So I could take this first 0 here on the left and change it to a 1. And now I've effectively changed the subnet mask from /24 to /25. In other words, if I convert this back to decimal, it's now 255.255.255.128. This completely changes the nature of the network. We now have a /25 subnet mask, and we only have 7 host bits.
All right, so the first step is in subnetting is to determine how many networks do you need. Okay, so you have one network ID, and you have 254 hosts. Okay, now you have to determine how many networks do you need. Again, this is based on your network, how you want to divide your network. You want to add, let's say, divide your network based on job functions, based on groups. So let's say you have 3 groups in your network: sales, marketing, and accounting. So you want 3 networks, okay? So based on that, you take the bits from the host portion and add it to the network. So how many networks do you need? So you take the bit, borrow the bit from the host, and add it to the network.
So starting from a /24, we now have borrowed 1 bit from the host portion. We call this 1 bit a subnet bit. If we look at it from the perspective that we started with /24, we've added 1 bit. So we could say that subnet bits, we now have 1 bit, or 2 to the first power, creating two subnetworks.
So now if we borrow 1 bit, we have two subnets, two networks. How many hosts we have in each network? Can anybody tell me? How do you calculate the host in each network? By calculating the remaining bits. 2 to the power of 7 gives you 128 hosts, and minus non-usable hosts, so you have 126. Okay.
Host bits, we have 7 zeros now. So host bits are 2 to the 7th power, or 128, minus 2 for the network address and the broadcast address, leaving us with a total number of possible hosts on the subnets of 126. So by borrowing 1 bit from the host portion of the address, we create 2 subnetworks, each subnetwork with 126 hosts. The subnetworks are the 192.168.1.0/25 subnetwork and the 192.168.1.128 subnetwork/25. We can prove that this is the case using logical ANDing to prove how the router or computer would take an IP address with this particular /25 subnet mask and derive the resulting network address. In other words, let's put in a host address. I'll put in the host address here, and I'll say, let's put in the address 68. So I changed this to a 68. So now we've got host 192.168.1.68. So this needs to be a 1. That's the 64. And then we need to add the 4-bit here. So now we have 68. If we logically AND the IP address here with our new subnet mask /25 here, let's see the result. We'll get a 1, a 1, a 0, 0, 0, 0, 0. So that's 192. And then here, the result is 101, 01, 168. And then all zeros here and a 1. This is a 1. And now, if we look at this last octet, a false and a true makes a false. A true and a false makes a false. And then we get all zeros here. So the address, the network address, is the 192.168.1.0 network. So host number 68 is on the 0 network. Well, this makes sense because if the next subnet is 128, if we...
So this is how computers know where the address is belonged to. If it's in the same network or it's in the different network.
Put in a host address larger than 128, we'll see if it falls in this subnetwork. So let's change it slightly. I'll change the host address to 138. So now I'll change this, put that as 0. So there's a 128.
Anyway, so you get the idea. The ANDing process determines which network a specific host belongs to. Okay. All right, so I'm gonna stop here. Okay, I'm gonna let you guys go over up until here because it's a long chapter, and we're gonna do an IPv4 network. We're gonna do this lab subnet and IPv4 network. Okay, so. Again, the idea in subnetting is borrow the the host portion from the network, borrow the bit from the host portion and add it to the network. Okay. And here's the thing.